Hi there and welcome to a quick video over L'Hopital's rule. And we use this rule when you get an indeterminate form of 0 over 0 or infinity over infinity when finding a limit. Now, I want to make this clear: when you're doing the infinity over infinity, or when your result is an infinity over infinity, it doesn't matter if they're both positive or if they're both negative, or if one is positive and one is negative. As long as you get a form of infinity over infinity, you have an indeterminate form. It is really important to remember to use L'Hopital's rule only when you have an indeterminate form. If you use it other times, when you don't get a 0 over 0 or an infinity over infinity, it will actually give you the wrong result. So make sure you only use it during these times. Okay, let's look at the first example. All right, the first example we're going to look at is the limit as x approaches 0 of sine of 5x over x. When you're doing limits, the first thing you always want to do is direct substitution. So we're going to go ahead and put in 0 everywhere we see an x and evaluate what we've got. If we do that, we get the sine of 5 times 0 over 0, which results in 0 over 0. This is an indeterminate form. Because the result was an indeterminate form, we are allowed to apply L'Hopital's rule. Okay, let's go ahead and apply L'Hopital's rule and see what that looks like. When we do that, we want to take the limit as x approaches 0, but we want to take the derivative with respect to x of the top separately from the derivative of the bottom. Do not confuse this with the quotient rule. You do not use the quotient rule when you apply L'Hopital's rule. You take the derivative of the numerator separately from the derivative of the denominator and then reevaluate your limit. So when we do this, we get the limit as x approaches 0 of cosine of 5x times 5, because we have to apply the chain rule, all over 1. And now we're going to put 0 back in for the x value and reevaluate. When we do that, the cosine of 0 turns into 1, and we have this multiplier of 5 all over 1, which equals 5. So the answer to this question is 5. And we have a very nice method of applying L'Hopital's rule to make that rather an easy problem, as long as you know how to take simple derivatives. All right, let's look at another example that's a little more complicated. The next example I want to look at is the limit as x approaches pi over 2 of 1 plus secant x over tangent of x. Again, we want to use direct substitution, and we want to put pi over 2 in for these guys. So we get 1 plus the secant of pi over 2 over the tangent of pi over 2. And we have a problem here, because when we put in pi over 2 for secant and for tangent, we get something that's undefined, because we have vertical asymptotes for secant and tangent at pi over 2. So what we need to do is we need to look at the limit from either side of that asymptote. So we actually need to evaluate the limit as x approaches pi over 2 from the right, and also the limit as x approaches pi over 2 from the left. Okay, in order to evaluate the left-hand and right-hand limit at pi over 2, we need to think about the graph. Let's start with the denominator. Let's think about the graph of the tangent of pi over 2. Here's a graph of the tangent of x. So if we look at what's happening right here at pi over 2, as we approach from the right, the tangent is going to negative infinity. As we approach pi over 2 from the left, we're going to positive infinity. So if we look at the graph, we can get the answers to our denominators. So for this one, the tangent of pi over 2 as we approach from the right was going to negative infinity, and the limit as x goes to pi over 2 from the left, the tangent of pi over 2 is going to positive infinity. So we have our denominators. Okay, then let's look at what's happening to the secant of pi over 2. This one is going to become insignificant, because these are going to either be positive or negative infinities. So to start with secant, let's look at the cosine graph, because the secant is the reciprocal of that. So if we look at our pi over 2 here, we've got our pi over 2, and the cosine there is 0. And because secant is the reciprocal of cosine, we can get the secant graph by taking the cosine graph and doing the reciprocal. Okay, and we can do this at every point where the cosine is maximized or minimized, the secant graph is created. Okay, and so we could keep doing that, but we're only concerned about what happens here. So the secant, as you approach from the left, the secant goes to positive infinity. As you approach from the right, the secant goes to negative infinity. So let's go ahead and add that to here. As we approach from the right, our secant was going to negative infinity, plus 1 is still negative infinity. As we approach from the left, we were going to positive infinity, plus 1 is still positive infinity. Because both of these are indeterminate forms, we can apply L'Hopital's rule. So let's go ahead and take the derivative of this numerator and the denominator and see what happens when we reevaluate at pi over 2. Okay, so this is what we need to do to apply L'Hopital's rule. The derivative of 1 plus secant x is, the derivative of 1 is 0. The derivative of secant x is secant x tangent x. The derivative of tangent x is secant squared x. And now we want to simplify. So this is going to eliminate that. That's going to eliminate that. Tangent x is the same as sine x divided by cosine x. And secant x is the same as 1 over cosine x. Instead of dividing by this fraction, what I'm going to do is I'm going to go ahead and multiply by the reciprocals. So instead of dividing by 1 divided by cosine x, I'm going to multiply by cosine x over 1, and when I simplify that, I'm left with sine x. So what we're doing now is we're evaluating the limit as x approaches pi over 2 of sine x, and when you do your direct substitution there, you want to evaluate sine of pi over 2. And again, if you think about the graph of sine of pi over 2, that's going to equal 1. So that is our solution to our original problem right here at the top. We should get 1 for that one. Okay, I hope this helps understanding L'Hopital's rule. It takes a lot of practice. Keep studying. Let me know if you have any questions.